Probability mass function versus probability density function. This lecture is for clarification of terminologies. That is, you should be very clear about the difference between a probability mass function and probability density function. These are similar concepts. So the main difference is in the type of random variable that is used. That is, for probability mass function is for discrete random variables, while probability density function is for continuous random variables. The first thing you have to understand is why it is called as probability mass function and density function, right? Let us take PMF first. Coming to probability mass function, why is it called as mass function? The reason is this. Coming to discrete random variables, we know, let's say there is a random variable x. It will take discrete values like 1, 2, 3, 4, etc. So it can be either a finite number of values or it can be countably infinite number of values. That is the definition for discrete random variables. So coming to these values, if I try to put it in this graph, let's say there are these values 1, 2, 3, 4 and so on. The word mass is used here in order to show that the probability is concentrated at specific points or masses in this complete distribution. That is, instead of the probability being everywhere here and there, it is specifically distributed as masses. That is, at 1 there is some particular probability, then at particular point 2 there is some probability, at 3 there is some probability. There is no particular probability in between 1 and 2. The only chances are either it can be at 1 or at 2 or at 3 or at 4 and so on. So to show that the probability is concentrated at specific points or masses in this probability distribution. In order to show this, we are using the word probability mass function, right? And what in the case of probability density function? In case of PDF, probability density function, here x is a continuous variable. So it is not taking discrete values like this. Instead, you can find x in a range of values. That is, let's say you can say from 0 to 4. What is the probability that x lies in the range 0 to 4? So in this case, it describes the density of probability over a continuous range of values. That is, in the same case, if you take here, you have 1, 2, 3, 4, etc. You this time don't have any particular value at probability of x equal to 2. Instead, you have a probability density function which says between the value, let's say 1 and 3, this much is the probability. So here you don't have particular mass of probability concentrated at each point. Instead, you have a probability density that is available in a range from 1 to 3 or let's say 2 to 3. So this is the reason why for continuous random variable you call it as PDF, probability density function, and for discrete random variable you call it as probability mass function. So here it is defined as, in case of probability mass function, it is defined as, let's say, P of x is equal to x, where the capital X, it is the random variable, and small x, it is the particular value that you want this random variable to take. But in case of the PDF, that is probability density function, you define it as some f of x, where this x is your random variable and f is a function. This function describes the density function, and if you integrate this density function over the range of values, that is, if I have an f of x, I have to find what is the probability that my x lies in 2 to 3. I have to integrate this over 2 to 3. I'll do 2 to 3 f of x dx. That is how I do it with probability density function. Coming to probability mass function, if I want to see for x equal to 2, I will simply put the value x is equal to 2 and calculate it. So this is the difference.